Let an be defined recursively by a of 1 is 1, and an plus 1 is equal to n plus 2 over n times an, for n greater than or equal to 1. Then a30 is equal to one of these possible options. Okay. It looks like there might be some kind of, well, actually, I'm not sure, like a telescoping thing going on here, or something like that. The way I'm going to do this, an plus 1 is equal to n plus 2 over n times an. What I'm going to do is I'm going to substitute this relation for an itself. All right, so this says that an is equal to, it's n plus 2 over n. Okay, so this becomes n plus 1 over n minus 1 times an minus 1. Okay, so if I substitute that into the first expression, I have n plus 2 times n plus 1 divided by n times n minus 1 times a n minus 1. And if I just keep doing this and go all the way back to where I have an index of 1 here, I'm going to keep getting, this decreasing sequence is going to continue. This decreasing sequence is going to continue. But we're going to get a lot of cancellation of terms. So if I do it one more step, for example, an minus 1 is equal to n over n minus 2 times a n minus 2. So then again, an plus 1 is equal to n plus 2, n plus 1 times n divided by n times n minus 1 times n minus 2 times a n minus 2. So and you see now that I have cancellation of things, and if I keep doing this, an n minus 1 will cancel, an n minus 2 will cancel, and so on. So what I want is a30. So let's let n be equal to 29. This says that a30 is equal to 31 times 30, and then a bunch of these are going to cancel, but I should also be left with, how many times do I have to do this resubstitution until I want, I want this to be a1. So I have to do the substitution several times, but the point is this term will not be canceled by something in the numerator, and this term will not be canceled by something in the numerator. But if this is equal to a1, then that term is a 1 and that's a 2. So a30 should be equal to this, which is 31 times 15, which is the first option given, option A. Yeah. Maybe there's, a slightly more elegant way of figuring this out. Writing down an expression that actually solved this recursion, if you can figure that out, right, like a proper expression for what an is. But I just thought, let's see what happens as we continue this pattern a few times. Another way of potentially doing it is compute the first few terms of the sequence. So rather than starting at the top and working backwards like this, maybe say, a1 is equal to 1. Well, then compute a2, compute a3, compute a4, and see if you can see the pattern. I kind of did the opposite. I wrote things as a two-step recursion here, and then as a three-step recursion, and I saw that there's going to be a lot of cancellations. yeah, not sure which way you might think is easier, but that's what I get. Option A, 15 times 31. Thanks for watching.